probability distribution of x bar take away mu over sigma over root n. When we take multiple random samples, each with n observations of a random variable x that has a population mean mu and a population standard deviation sigma, we can calculate the following statistic for each sample. Z equals x bar take away mu over sigma over root n. Well, we've called it Z, which is a bit of a giveaway, but look, x bar take away mu over a standard deviation, it is a Z score. Key points. Approximate normality. For large sample sizes, and here we've got our magic number, n is greater than or equal to 30, the distribution of Z is approximately normal with a mean of 0 and a standard deviation of 1. So what we're saying there is that this would follow normal 0, 1. And we used that in the last two examples, if you think about it. This is a direct result of the central limit theorem. Behavior with increasing sample size. And this is referring back to the investigation stuff that we did. As the number of samples increases, the frequency distribution of Z becomes smoother and better approximates the standard normal distribution. Larger sample sizes lead to a more accurate approximation of the normal distribution, making it easier to apply statistical tests. We saw this in the investigation part, where taking larger sample sizes smoothed out any skewness that was in the underlying data. Applications. This distribution is commonly used in hypothesis testing, and we did a sort of proto-hypothesis test in the last two examples. And confidence interval estimation, that's what we're coming on to next, especially when evaluating whether a sample mean differs significantly from the population mean. Again, something we saw in the last two examples in a sort of testing scenario where we were looking at whether the mean of our sample was an unusual one.